Good morning, yes. My name is Mike Long. I'm a continuous delivery and DevOps consultant based in Norway. Today I want to talk about DevOps, why I believe it ushers in a new paradigm, and what we should do about it. I have more or less stolen all the ideas for this talk from this book. It's a great book. It was written by Thomas Kuhn in the late 60s, and it was groundbreaking at the time, because what it did was it smashed apart how science actually works, how the field of science actually progresses, and provided a new pattern for how to think about progress, actually. Up until this point, there was this idea of the Popper method, and this is kind of how we're taught what the scientific method is, when we're students, at least, when we're studying at school. The idea is we make observations, we think of interesting questions, we formulate hypotheses that are testable, we develop testable predictions based on our hypothesis, and then we gather data. And then we go around this loop, and slowly but surely we incrementally improve our knowledge of the world. This is the textbook answer to how does science work. The thing is, though, that's not really how science has progressed in history. In fact, Kuhn found something completely different. So what he found was actually science, for the most part, progresses with revolutions, where the field has to be completely reconstructed from fundamentals. The textbook have to be thrown out, and what we think of the world is completely shifted. And this happens again and again through history. And he proposed a cycle for how these revolutions work. So, for the most part, we operate within a paradigm. There is normal science, and it operates within a worldview. This is kind of the paradigm that he mentions. I should say, actually, that Kuhn is the man responsible for the term paradigm shift. So the idea between normal science is kind of like that Popper method of incremental inquiry. You're trying to bring nature and theory into closer agreement. The important thing is that during normal science, you can take for granted the basis of your field. The textbooks are not being rewritten. Generally, there's curriculum available. There's a broad understanding of the way things should be. The Large Hadron Collider and Dolly the Sheep are examples of normal science, because these projects actually got the results they more or less expected to get. So this is the interesting thing, actually, that happens in normal science, is that generally you get the answers you expect. Now, the thing is, over time, unresolved anomalies accumulate, and some scientists start to question the paradigm itself. But the community will retain the paradigm until there is a better answer. So you can't question, the field doesn't leave a paradigm until we have a better solution. If these anomalies accumulate to the point that they're overwhelming, there becomes what's called a crisis. And this is when the scientists in the field start to rethink the fundamentals of the field. There's a lot of arguments, there's a lot of discussion. People start to question the basis of the field. The only way to get out of a crisis is with a new theory. And this is what sparks the revolution. The crisis is resolved by a new theory, and it provides this revolutionary world change. And the previous paradigm is completely left behind, and we get our paradigm change. The important thing about a paradigm is that a scientific field can only operate in one paradigm. It's not possible to have two competing paradigms going for a long period of time. And actually, if that is the case, actually what you're in is a state of crisis, because the fundamentals of the field are not taken for granted. So this is how he sees scientific progress. It goes largely in periods of paradigms of normal science and revolutions. Normal science and revolutions. To give some examples, for most of human history, we believed in the Earth being the center of the universe, and that made a lot of sense. We could make observations and see everything was flying past us. The sun would go past us every day. The moon would go past us every night. It makes sense. But later, Copernicus with his telescope and Kepler making his tables of data we're able to realize that, well, maybe not. What if instead of everything going around us, everything went around the sun? That might give us a different worldview. And then not too long, we had another revolution, 50 years later, with Newton, saying, well, what if the way that we go around the sun is also the same way a cannonball flies through the air? What about if we could unify this into some general law or principle? And that's what he discovered, the Newton's laws and Newtonian physics. Then we had our new paradigm, which lasted for a long, long time. Up until this point, it was believed that there was different laws governing the celestial bodies from the bodies on the Earth. And that lasted quite a while until we started to dig more into electromagnetism and so on. And then Einstein had some different ideas about actually the fundamental nature of science, of the universe. What he said is, okay, what if space and time are not fixed, but the speed of light is, and the rest is all kind of bendable? Wouldn't that be interesting? And then we had a new world to live in, and that gave us GPS and other kinds of fun things, atomic weapons, and so on. So that's how science progresses. How does this relate to software? So I want to argue that we see the same pattern in software. We have a much younger field, but we've seen it again and again that we go through periods of normal science where everyone agrees on paradigms until there's a crisis. And I want to take you through some of these. So the field of software, I argue, you could say it was Lovelace and Babbage and so on, but I argue it really starts with Turing, because this is when we had programmable machines. And so we are a relatively young field. The mid-40s, this paper was published. And it wasn't that long later that we already came into a crisis. And it was actually called the software crisis at the time. And all the leading thinkers in the industry got together for the NATO Software Engineering Conference in 1968. So that was just over 20 years later that we had our first crisis. And what Dijkstra was saying is, okay, when we had simple computers, then actually programming was quite simple. It was a tractable problem. But the machines get more and more complex, and the software becomes larger and larger, and we don't know what to do. We need to find our way. And actually, the name of this conference gives a hint at what they thought the solution was. It's engineering, software engineering. Our industry, our field of software decided that the way out of this crisis, the way to deal with complexity, is to adopt the principles and practices of engineering. So this is what I would call the normal science. We had a paradigm there. We had this idea that what we were doing is we were building bridges. We were civil engineers in a sense. We would plan, we would be careful, we would think things through, and we would design our systems and we'd build them, just like bridge builders do. So we got a lot of techniques to help us in this. We had structured systems analysis and design, structured programming, data hiding, object-oriented programming, all those things that we kind of take for granted now, all the groundwork, languages, libraries, components, all that stuff came in this era of engineering, I would argue. And it worked great. It worked really great. I mean, our industry made a huge amount of progress between 1968 and 1998. The next 30 years were tremendously successful for our field. The thing is, though, anomalies started to show up. I don't know if any of you have seen this Wikipedia page before, but there's a Wikipedia page for failed software projects. If you ever have 5 minutes in a coffee break, there's some fantastically fun reading here. I think most countries are represented in the list, and some of them are spectacular, the software failures that have occurred. We're in the UK, so yes, it's a bit hard to read, but here's the Electronic and Records Program for the National Health Service. It cost 12 billion. And it was a complete failure. Nothing went into production from that. 12 billion pounds of taxpayers' money disappeared. Now, they were doing things the right way. They had requirements documents. They were probably using CMMI level 5 consultants. All the right principles and practices were followed, but these projects were still failing. And it seemed like we'd gotten to a stage in history where our projects were becoming so big that they were almost guaranteed to fail. There was other kind of anomalies kind of creeping up as well. There was the free and open source movements. There was GNU, there was Linux, there was all kinds of projects who were making very, very large software systems without any of the software engineering methods. They were not having design reviews. They were not having requirements documents. It was a completely different setup. And yet they were succeeding. How is it that these big, complex, distributed projects could succeed without using engineering principles? So then we get to our crisis. During the mid to late 90s, there was a lot of argument in the field. We're doing this wrong. Now, there was a lot of people advocating for, okay, what we need is more engineering. What if we went to model-driven development and so on? That never really came to fruition, but a lot of people were starting to wonder, what if instead of building bridges, what we were trying to do, actually software, is we want to think of our technical organizations as factories that deliver change. And we want to optimize our factory floor for delivering change. The customer requests are getting met, and we want to apply the same principles that Toyota uses in its factories to the way we make software. That was very interesting. It didn't make a lot of sense to a lot of people. There was a lot of pushback against these ideas. And in fact, there was a lot of argument. The people that signed the Agile Manifesto had spent the previous 10 years arguing about the best way to make software. But in the end, it turns out that there were some things that they could agree on. They could agree on that it's important that we want to make sure that people are central, that we need working software, not documentation, and so on. So they found a way to kind of distill what we should do as a field. They came up with a new theory. Maybe we have a new way of thinking about the way we make software. And a little bit later, we got some principles for the Agile Manifesto. I think they came a year later. And the very first principle says, our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Also the first time that the term continuous delivery is applied to the world of software. So this is interesting. Now we have a new theory. But anyone can come up with a theory, right? It's not enough to have a theory. Actually, what you need to spark a revolution is more than the theory. You need achievements. You need some sufficiently unprecedented achievements, and they also have to be sufficiently open-ended. Now, this is really important, because if you come with the solution, the answer to everything, you're not going to interest anyone. We're all engineers. So, and the same is for scientists. If you create a new theory for your field that's complete, then what is there left for all the other scientists to do? There's nothing for them to fill in. There's no reason for them to get interested in this field. So this is what was missing at this stage. We had a manifesto, we had an idea, we had some principles, but we didn't have any real achievements with this out in the wild. And there were still, everything was still open-ended, so that made Agile quite interesting, because there was nothing really figured out then. There was still a lot of arguments. And I would say that the revolution really came when we started to hear from companies like Flickr, who were actually managing to be agile. They were delivering change to their customers on a regular, frequent basis. At the time when Flickr talked about 10 deploys per day, that was seen as incredibly impossible. Most software projects were delivering on a +1 year cadence. And I mean, there still are companies and projects that work on this. So to be able to go from more than a year deployment span to 10 times a day, it seems incredible, but it was possible. And those achievements started to gather people, and we started to become interested in this thing called DevOps. It wasn't the fact that Agile wasn't interesting, but people were trying Scrum, trying different things, but they weren't really getting this continuous delivery of value to the customer. So this is where the DevOps enters the picture. Now, when you get a revolution, there's there's a fantastic opportunity for new tools and for organizations to retool. So retooling is expensive. There's no getting around it. Changing your tools is expensive. But a revolution kind of forces that. If you have a new paradigm, then you're kind of pushed to pick up new tools. You can't keep working on monolithic COBOL databases that are strictly bound to databases at the same time as deploying 10 times a day. They're just incompatible tools. So if you're interested and you want to be part of this new paradigm, then you have to move and change your tools. And you see this, especially in the banking sector, where the companies are being really fast to adopt to microservices and cloud-native technologies and so on. So the role of tools in science has been instrumental, of course. I mean, without Galileo developing the telescope, Kepler wouldn't have been able to gather the data that was so instrumental for Isaac Newton to prove his theories of the laws of gravitation and so on. Again, Galileo, if he didn't have invented the compound microscope, there's many, many investigations into microbiography, basically cells. We wouldn't have cell theory without people inventing the tools to make it possible. Medicine is an interesting field as well, because here, up until the 19th century, the way scientists, doctors figured out what was wrong with you was to cut you up after you were dead. And that's not an ideal way to figure out what's wrong with you. So René Laennec figured out that, well, if we could just hear a little bit more of what's going on inside, then maybe we could diagnose a little bit better. So for years, he gathered data. He'd stethoscope up to sick people's ears, and when they died, he'd cut them open and figure out what sounds related to tuberculosis and so on. So it was very interesting. And then we get like the start of non-invasive medicine. And you can see from the 19th century and onwards, there's been a lot of development in this field, but it's, again, driven by tools and data. You could even stretch the metaphor to evolution. Without ocean-going voyages, if we didn't have compass navigation and shipbuilding, we wouldn't have ocean voyages. We wouldn't have the Beagle expedition, which was where all the data was gathered that gave Darwin the insight to be able to write The Origin of Species. Sometimes it works a different way. Sometimes the theory comes first. It's not always tool data theory. Sometimes the theory comes first. So we have this idea that in the 60s that there's this thing called the Higgs mechanism and the Higgs field. But it took until 2008 before we'd actually built something that could test for that. And then in 2012, of course, it was proven that there is a Higgs boson, and we could find it. And there was it was a great moment for physics. But they're all tied together. Higgs boson wouldn't be known without the theory, without the tools, and without the data. You need all three. Because without them, it's just theory. It doesn't count for anything. So if we need tools and data, where do we have the tools and data to back up that we believe Agile can improve business outcomes? This is the missing part. We need the tools and we need the data. Thankfully, the thing about our field is that we're really good at making tools, right? This is one of our favorite things to do. So between 2008 and now, just think of the amount of tools that have been created in the space of DevOps, microservices, cloud delivery. It's incredible. We're entering into this world of new normal science now, where we need to build the tools, we need to do the data gathering, we need to actually stand on our feet and test the theory and gather the data and make sure we're doing the right things. So one of the steps that we've taken in this direction is to start to turn everything into code. Right? We're turning our cloud infrastructure into code. We're talking about our testing as code. We're talking about our configurations as code. Everything is code. Whatever we want to do, we want to automate it in some ways and make sure that everybody that's involved in this is in one team. This is the paradigm that we're in now. Now, if we don't have to worry too much about the details of this, but you can think of a software organization or any kind of technical organization has a reason to exist, and that's to take a need and to deliver the need. That's the only two reasons it exists. Well, that's actually just one reason, but the point is that from the need to the need being met is the only thing that's interesting in your organization. It's the only thing that matters. Now, how you get from there to there will be different for every organization. It will be messy. It will involve all kinds of things that you would rather didn't exist, different teams, different processes, different tools. But you need to always keep in mind that the only reason that your organization exists is to meet the needs of the business. And you need to think about your system, your organization, as the factory floor, as the car parts. You want to optimize for the flow of change. So we're building our tools. We're trying to help automate that process, the flow of value in our system. And we've been building a lot. How many people in this room are using at least one of these tools? Okay, that's nearly everyone. And all of these tools are invented in the last 10 years. I think that the adoption rate of our new tools is really impressive in our industry, and it's not going to slow down. This is an important part of us exploring this new space that we've figured out. We're on the factory floor. We're still figuring this stuff out, and that's why it's a super interesting time to be part of this field. So that's the tools, but where's the data? We need the data. There's a great organization called DORA, DevOps Research Association, and they do an annual survey of IT professionals, and they survey thousands of organizations. And they gather the data. The important thing is that they ask scientifically valid questions in their surveys. It's not a marketing survey. They actually ask questions that lead to data that can be used. And a lot of their findings are published in peer-reviewed papers. Great organization. You might have heard of the State of DevOps report. This is the annual report that they send out that summarizes their findings. It's a great report. It's free. You have to give your email address. But it's really worth it. And they're finding that actually the differences between the best performers and the worst performers are massive, which we all already know. We've been in this industry. We know that there's some great organizations that are fantastic, and we also know that there's a lot of people still living like it's 1968. It's just the way it is. So we're starting to get good numbers about this, and this is important at the industry level, but it's not enough to get the numbers. You have to find out what the cause and effect is. So this is one of their diagrams in the report. It basically shows that from the answers in the question, how they can figure out what the cause and effect of the different drivers in the organization are. It's too much to get into now, but what they're trying to link to is financial outcomes. What is the truth to the theory that Agile can inform business outcomes? So they're starting here. What are the business outcomes that are measurable? What feeds them? Well, lean practices, lean product management, and lean product design, continuous delivery. And well, to do lean product management, you need transformational leadership. To do continuous delivery, you need a lot of practices and tools. So there's a lot of cause and effect that we're starting to discover and be able to actually prove. And this is great progress for our field, which is a lot driven by buzzwords and fads. Now you can start yourself thinking about this in your organization. These are very simple things to measure. How long does it take for a need to be met in your organization? That's a fantastic metric to have in your organization, because that's, like I say, the only thing that's important. You can start to get fancier to think about how long it takes for deployment, how long it takes for build, how long the development lead time is, and so on. But these are all measurements you can get from your version control system, your task management system. They're easy to measure, and they're really valuable. The place to start, of course, is to get everybody who has any say from the need to the final delivery to be involved and to figure out what your value stream actually is. Not just what you're doing in your development teams or your operations teams. What is the full value stream? And map it out on the wall. I guarantee you when you do this, it's going to be messy, and there's going to be lots of loops and rework and queues and all kinds of things. But this is good, because you start to surface it. It's very valuable. Okay, so now that we're in this paradigm, we're in this area of normal science, how do we adapt to this new paradigm? Andrew Grove has a fantastic book. Actually, he's got many fantastic books, but this is one of my favorites. It's called Only the Paranoid Survive. Andy Grove was the CEO of Intel, and he took Intel from being primarily in the memory business to being primarily CPU business. And he did that because he could see that there was more and more and more competition driving down the prices of memory. But CPUs were a tiny part of their business, so it was an extremely risky bet to try and move a whole organization and a whole culture from one set of incentives to another set of incentives. He has a fantastic book all about this. One of the key things that he talks about in this book is this concept of strategic inflection point. And what he realized was that if he didn't get out of the memory business, his business is going to decline. It's just as simple as that. There was more and more competition. The prices were going further and further down. There's just no way to win in that kind of market. He had to figure out that this was an important time to change and absolutely necessary. And I would argue that this is the same thing with DevOps and Agile. A lot of people talk about Agile, and they do Scrum, and they might do retrospectives, and they might do a lot of the ceremonies that are important. But when it comes to continuous delivery of value to the customer, I see time and time again that that's not the focus. And I think that this is the strategic inflection point, because those companies that can meet the customer need faster obviously will do better in the marketplace. The good news is that the future is already here, and it's not evenly distributed, so there's a lot of people that are doing great work, like the Flickr example and so on. There's people that are living in the future that we can learn from. We don't want to be the first to adopt new technologies and new tools, obviously, because everything new is broken. That's just the way things are. But you don't want to be the last to adopt all these new tools and technologies either. So you need to think strategically about what makes sense and what your strategy is. An important thing is, because this new paradigm is in flux, there's a lot of tools being made all the time. You want to, whatever decision you make, you want to avoid lock-in. You want to design your strategy that you can replace any part going forward. And then, of course, come to conferences like this, learn from the community, make sure that you have an overview of what's going on, what people are learning out there. So yes, that's what my argument is. I think that DevOps does define our paradigm. I think Agile was the theory that sparked it, but DevOps is what gives us the tools and the data to be able to actually achieve the promise of the theory. So DevOps is the practice we need to adopt to actually be agile. So now that we're in this, we need to think about our tools and our data and understand that this is actually a strategic inflection point. Thank you for your time. I'll be around today and tomorrow. I just want to say enjoy the rest of the conference, and if you have any comments or questions or want to talk to me more about this, I'll be around. Thank you.